Hello and welcome to EELE 101, Introduction to C Programming. This is our second week, and so for this week we will look at data types. And the data types will be characters, character arrays, also known as strings, integers, floating point data types, and there are two types known as floats and doubles. Okay, so looking at characters first, characters are a basic type in C. They take up 1 byte in memory, or 8 bits. And to reserve memory, we use the keyword char, and then we give a variable name. Okay, so what this does is tells the compiler to reserve a byte in memory. And so for argument's sake, we will say it's located at memory location 2, and we will give the variable name and call it letter. So instead of having to remember the memory address location, which in this case 2 would be fairly easy to remember, but it could be a big long number that would be hard to remember, and so we just say, okay, just reserve a letter, and that location is called letter. And so now we can assign the letter H to that memory location, and it will stick H into the location that letter tells us to put it. Okay, so back in the 60s there was a chart. This is known as the ASCII chart. It was 7 bits, which means that there is 127 characters and other control sequences that was specified. We had all the letters in the English language, both uppercase and lowercase, numbers, and other characters. But that's pretty limiting today, so there is now Unicode, which instead of 7 bits is actually 32 bits, and so that actually contains more than 110,000 characters. That pretty much covers all the characters in all the languages of the world. Okay, but we won't concern ourselves with that. We will concern ourselves with the basic C char, which stores a single letter. That's 8 bits. Okay, so when we say char letter, there's actually that memory spot reserved. Okay, and when we assign H that letter, the actual binary code that's put in here is 01001000. Okay, so where did that come from? Well, if we look at the table here, we see that H is represented by the hex code 48. Okay, so here's hex 48. And so 4 is 0100 and 8 is 1000. Okay, and that's actually the binary value that will be stuck at that memory location, indicating the character H. Okay, so a sequence of characters is called a string, and what you have to know about strings in C is that all strings end with the null character /0. Okay, so to hold a string, we need to create an array that holds all the characters that we want to have, to save at that location, plus the null character. So there's always n+1 memory locations that we need. Okay, and so there's a lot of functions that process strings, and they just go through memory until they see the null character and stop. So the printf statement function that you're using does this. Okay, so let's create an array that holds the string hello world, and if you count that, hello world, that's 11 characters long if you count the space between the two words. So we need an array of characters that's 12 characters. Okay, that will include the null character. Okay, so we tell the compiler, okay, here the data type is char. Our array name is string1, and then we're going to tell it how many places to reserve in memory. Okay, and we do that with the square brackets. Okay, so this tells the compiler that we want string pointing to some place in memory that can hold 12 characters, and we leave it up to the compiler to put it anywhere in memory it wants to. We just say if we refer to string, just that will point us to the memory location. Okay, so here's an example here where we can assign the string and put it in memory with the actual characters that we want by making this assignment as we tell the compiler to create space for us. There's a shorthand where, okay, if we really don't want to sit there and count how many characters are in the string we're typing, just don't put a number inside the square brackets there, and the compiler will count the number for us and also put a null character at the end. So here we can say, let's say for instance that the compiler says string is actually going to start at location 2. It's going to actually reserve all this space, put the hello world in there, one character at a time, and then it ends with the null character, and that always indicates that that's the end of the string. Okay, so now we don't have to worry about where this is in memory. We just refer to string1 that points to the beginning of that array. Okay, so to print a string, we need the printf function, and we need the special command code %s. Okay, because that will insert a string in the printf statement. Okay, so let's assume that we had created the string that was filled with hello world. Okay, and now we want to print that string out. So what we do, we use the printf statement. Okay, we now notice we have the double quotes here, and inside the double quotes we're going to do the %s, because that tells us put the string there. We have the /n, which is a line feed, and the %s tells to insert a string, but which one is it? Okay, well, we have to tell the function which string is going to get inserted there. Okay, so we have the argument that is the variable or array string that we created right here. Okay, so we're going to print a string. Printf will print the string wherever we place the %s, and then we have to give it the string to insert at that location. Okay, so there are a number of string functions that we can use. Okay, so let's look at a couple of them. First, let's create an array with plenty of character space. So for instance here, we will leave room for up to 99 characters, because we always need the one at the end to be the null character. So we can copy a string into the array with the string copy function. Okay, so here we tell it the array where we want the string put, and now we give it the arbitrary string enclosed by the double quotes, and that will be copied to that string. Now, if you want to see more information on that function, a good place to look at that is at the cplus.com, the reference, and the C string library, and the string copy function in that library. Okay, so let's create a second string. Here we're going to do it slightly different. We're going to let the compiler count how many locations it needs. So we're going to give it the string 1, 2, 3, 4, 5, 6. It's actually going to reserve 7 locations because it will always put a null character at the end. And now we want to concatenate those two strings, or append string to the end of string 1 by using the string cat function, and that stands for concatenation. So here we just say string cat the destination string is first. The string we want added to the first string here is the second argument. Okay, and again, you can look it up on the web on the reference of that function. Okay, now to use either string cat or string copy, we need to include the string.h header at the beginning of the program, because that tells us, it indicates to the compiler that the information for string cat and string copy is located there. Okay, so create a project like you did for assignment 1 and just type in the following code and try it out. Okay, so we are going to include standard io.h, the string.h, because we're going to use the string copy and string cat. Okay, we always need to start with our main function. That's the entry point into our code. We are going to enclose our statements in curly braces. That tells us all these statements here are part of the main function. Okay, the first line here is, let's create an array called string1 that can hold 100 characters or 99 characters plus the null. We're going to create a string2 that holds the string 1, 2, 3, 4, 5, 6. We're going to copy A, B, C, D, E, F to string1. And now let's print out both strings. So again, in the printf, we're going to use the %s that tells us where to insert the string, and then we have to tell it which string to, where's the information coming from? What string is actually containing the characters we want printed out? Okay, so that will print the two strings. Now we will append string2 to string1. So we're going to do that with the string cat and print out string1 again. So now that should have the second string appended. So run this, and do you get what you would expect when you do that? Alright, so we also want to get user input, and we will want to get a string from the user, and we do this with the fgets function. Okay, so here we're going to create string1 again that can hold 100 characters. And now fgets has 3 arguments. Okay, the first argument is if somebody types something at the command line, where are we going to store that? Okay, well, we want to store that in string1, so we have to first create it, and now we have to tell it where, what array to put the characters in that we type in. Okay, so we created string1 for that purpose. We have to tell fgets how many characters to read in. So we don't want to read in more characters than we can store. So we're going to say size of string1, because size of tells how many characters that string1 can hold. And then the third argument is, where are the characters coming from? In this case, it's standard in. And standard in is typically the console window. So when that console window opens up and you type something in there, that's where it's going to take the characters. Okay, now one thing you should note is when fgets grabs the user input and you hit the enter key, okay, it will insert a new line character in the string. So if you print it out, that /n new line character will cause a line feed to occur. Okay, so just be aware that that's happening. So once we get to if then else statements, we will show you how to, in a sense, remove that character. But for now, we'll just leave it in. And if you see things printed on 2 lines, that's the reason. Okay, now try out the next code segment. So you can just quickly type this into another project. So here we're going to create a string that's going to contain the characters that we are going to type in. Let's create a prompt. So here we'll say enter your first name. We're going to grab whatever you type in until you hit the enter key, and that's going to be fgets. Okay, where are we putting the characters you type in? Well, it's string 1. What's the maximum we are going to allow coming in? Well, it's the number of characters that string 1 can hold, so it's size of string 1. And where's the data coming from, or the characters coming from? Well, it's standard in, which is the command window. All right. So once people have typed in their first name, then let's print it out, and we just say first name equals. Okay, well, let's print out whatever's in that string. So we have to use the %s, and that string will get inserted at that location. Okay, so again, notice the double quotes here. We can print out whatever we want, but where we want the string inserted, we do %s, and then /n is a new line. Okay, so run this and see what you get. All right, so your first assignment, you will need to write a C program that does the following. 1, ask the user for their first name. Okay, you're going to create a character array called first name. Then you're going to ask the user for their last name and put this in the array called last name. Okay, now you're going to create a third character array called full name. Okay, and now what you're going to do is first copy first name to full name, and then concatenate the last name to the full name. Okay, so the person will enter their first name, their last name, but you're going to create a third array that has both the first and last names in there. So you need to use the string copy function, and you'll need to use the string cat function to catenate it. And then what you'll do is actually print out the third string and have it state your full name is, and then have both the first and last name, okay, printed out coming from the third character array, and you'll be using just a single %s to print that out. Okay, and when you create these arrays, just make sure they're big enough that they can hold, pretty long name. Okay, so that's the first assignment you'll need to do. Okay, so again, it's very similar to what we just saw here, where you're going to use the string copy and the string cat, and then you will use the fget. So if you actually run these two programs, see how they work, it's just pretty much the same thing. Okay, just a little bit more specific on what you need to do here. All right, so that's assignment 1. Okay, let's move on to integers. You can create an integer type by the following. You have the keyword int that says we're going to create a variable of type integer. All right, now the actual size of the integer depends on the CPU register size. Okay, so if your CPU is a 32-bit CPU, the int will be 32 bits. If it's a microcontroller and one of the smaller ones that say it's 16 bits, then int will be a 16-bit. Okay. Now, since we're targeting a microcontroller that is a 32-bit machine, we will assume here that an integer is 32 bits. Okay. Now, integers can be modified by the keywords signed, unsigned, short, and long. So if I said signed int c, what I'm telling the compiler is reserve a location in memory that's 32 bits, and the integers then can range from -2 billion to +2 billion. Now I can also say unsigned, and so essentially we don't care about negative numbers, so we will be able to store values from 0 to a bit over 4 billion. A short int is essentially half an integer, so this will be a 16-bit variable, which can also be signed or unsigned. So we could say unsigned short int. Okay, a long int is twice the int, which is 32, so in this case it would be 64-bit, and so we could also have it signed or unsigned, so we could say signed long int. Okay, but for now we will primarily just use integers. Okay, so how do you print out an integer? Okay, so in the printf function, we need the command code, the print command code %d. Okay, so let's create two integer variables. Let's assign integer I to be 5 and the variable j to be 6. And now we'll just print out the statement, the integer I equals, okay, here's the %d, so we're going to stick an integer there, and we're saying integer j is %d. Okay, so we want to stick an integer there. Well, what integers? Okay, well, %d is going to be associated with the first argument, so this is the first command code, so this gets associated with the first argument here. The second command code gets associated with the second argument here, which is j. All right, so %d tells where to insert these integers, okay, and then we have to have the variables that will get inserted in that printf statement. So when we run this, this will say the integer I equals, well, in this case it will be 5, and the integer j will be, in this case, 6. All right, we can convert a string to an integer, okay, because a string is really a character, it's not an integer. So we can do this by a special conversion function, a to I, or ASCII to integer. Okay, and so if we do that, we need the include statement standard lib to be included if we're going to use that function, right? If you want to see more details about it, here's the reference for it. Okay, so here's a simple program that you should try out. So let's reserve a location for a character array of 100 characters. We want an integer k, so k will be an integer. Now we will print a prompt and we'll say enter a 6-digit number. Well, let's capture that number. Now notice when you type in the 3, 4, 5, 6, 7, 8, okay, those are characters coming in, and those will be put in string 1. And and it's coming from you're typing actual characters. Okay, well, we want this to be a number that's an integer, so we actually have to convert that. Okay, so that's how we do it here. So k, which is an integer, will be whatever the result is of string 1 converted to an integer. And now let's print that number as an integer using the %d, and of course we need the variable name that stores the integer we want printed. Okay, so try this code out to see how you can convert a string to an integer. Okay, and now in many scientific computing scenarios, we want to represent very large or very small numbers. Okay, so integers aren't a good way of doing that because we count 1, 2, 3, but what if we wanted 3.5? Okay, well, we can't use an integer. So what we're going to do then is we have two floating point data types, either known as a float or a double. Okay, we essentially represent that with some significant digits, but the key here is we're actually using an exponential notation of the numbers. Okay, so we can get very small numbers by saying 2 to the minus 126, or pretty large numbers of 2 to the 127. And the approximate decimal would be 10 to the minus 44, which is pretty small, or 10 to the 38th power, which is pretty big. Well, sometimes that's not small enough or not big enough, so we can double the representation here. So if we do that, we can represent numbers as small as 10 to the minus 323 to numbers as large as 10 to 308, which is covers pretty good ground in terms of the numbers you need represented. Okay, well, if you want a 32-bit single precision floating point, then you would just say float A. So A would be a single precision floating point variable. If we need twice that precision or double precision, then we would just say double B, and so B would be a number that could be represented anywhere within this range. Okay, so to print a float or double, we have another command code, and this is %f. So here we're going to, so let's first let A be a float, a floating point number. Let B be a double, or twice the range that a float can be. And now let's assign 5.3 to A and 0.00002 to B. And now let's print that out. And so here we can say the float A equals %f. We're going to insert a floating point number there. And the double B is %f. We want another floating point number there. Okay, well, which floating points? Well, associated with the first command, print command, will be A, and with the second will be B. So A is going to get printed out there, and B is going to get printed out there. And so when this gets printed out, it will say the float A equals, well, A is 5.3, and the double B equals, and it'll print out 0.0002. Okay. All right, we can convert a string to a double just like we did to an integer, except we use A to F, or ASCII to float. Okay, conversion function. Again, we need the standard library H at the beginning of our program via the include statement. Okay, so try out this code. We have standard IOH, we have standard lib because we want the conversion function. Again, let's create input array. We're going to now have K, which is now a double. Okay, and now with the prompt we're going to present to the user is enter a real number with a fraction part. Okay, we're going to capture that string, and now we're going to convert that string to a float with that A to F function. And now let's print out the floating point number via the %f, and K here is the floating point number, and that's going to get inserted there when the printf statement runs. So try this code out. Okay, so you can print floating point numbers. Alright, so assignment number 2, which is just an extension of assignment number 1. Okay, so again, you're going to ask a person for their first name, you're going to ask for their last name, you're then going to ask the person for their age, and of course this is going to be stored in a third character array. You're going to ask them to enter the value of pi and ask them to enter as many digits as they can remember, and you're going to put this in a fourth character array. Okay, well, now you're going to have to convert age to an integer, so you're going to use the a to I function. You're going to convert pi, the pi string, to a double. You're going to use the a to f function, and now you're going to use a single printf statement to print the following, which will say first name, last name, who is 27 years old, entered the following number for pi, and then you print out what they entered. Okay, so there should be 2 %s's. Okay, one's for the first name, the second one's for the last name. There's going to be 1% D, which is going to be for the age, and there's going to be 1% F, okay, for the pi value. Now, so you have to convert this to an integer to use the %d, and you have to use the a2f to use the %f function. Okay, so now you have to create a program that will do the following.